Today's lesson is 6.1, Introduction to Rational Expressions. A rational expression is a quotient of two polynomials, p of x divided by q of x. Like any fraction, a rational expression can be simplified. To simplify a rational expression, what we are going to need to do is to factor the polynomials. Determine if there are any factors that are the same, and then we can go ahead and cancel out any like factors. Let's go ahead with sticking with something that we know, and let's simplify a fraction, like 9 over 15. So I can take my fraction, 9 over 15, and I can think of it as 3 times 3 in the numerator. 3 times 3 is 9. And in the denominator, I can think of 15 as 3 times 5. Now, what I can very easily see is that there have a 3 in the top and a 3 in the bottom. Because they are in the top and the bottom, they can cancel each other out, leaving me with a 3 in the numerator and a 5 in the denominator, which is my simplified fraction of 3/5. This would be my solution. Okay, let's go ahead and make this a rational expression and take a look at two polynomials. So x squared plus 6x plus 9 would be my p of x, and x squared plus 8x plus 15 would be my q of x. These are my two polynomials. Let's go ahead and factor them. So remember, my quick little trick said we're going to take a look at the x squared term, and we're going to think x squared would be x times x. And then we're going to take a look at the c term, the 9, and we need to think of it as, well, it could be 1 times 9, or it could be 3 times 3. We're going to take a look at the middle term, the b term, and we're going to say, well, I need 6. So I know that 3 plus 3 is 6, so I'm going to go ahead and try 3 times 3 for 9. I'm going to go ahead and cross multiply, giving me 3x. And this one gives me 3x as well. And when I add those together, I can easily see that I do get my 6x. Because my 3's are both positive, I put a plus. And my two factors are x plus 3 times x plus 3 for my numerator's polynomial. Let's go ahead and factor the denominator's polynomial. So once again, we see x squared, so we're going to think of that as x times x. And then we have 15. We could think of that as 1 times 15, or it could be 3 times 5. We're going to make our decision based on what b is. B is 8. So 3 plus 5 is 8, so I'm going to go ahead and use 3 times 5 for 15. I'm going to crisscross multiply 3x, crisscross multiply 5x. I add these together and I can easily see that I get my b term of 8x. Because everything is positive, once again, I have my x plus 3 and I have my x plus 5 in the denominator. Just like in a fraction, I can go ahead and cross out like terms in the numerator and the denominator, the top and the bottom. So I see that there's a plus 3x and a plus 3x. Now, don't be confused. These terms are completely gone. These factors are completely gone, leaving us with our solution of x plus 3 over x plus 5. Now, it is very common that you go ahead and drop the parentheses. I like to keep them because they have to stick together. These are factors, and so they cannot be separated. You cannot go ahead and cross out the x's. Okay, you cannot do this. Let me show it to you. You cannot do this because these have to stay together as factors of the polynomials. Let me show it to you another way. Let's say that in our answer, x plus 3 over x plus 5, you think that you can cross out the x's, and you're seeing that your answer would be 3 over 5. Okay, so let's go ahead and let's think of x being equal to 2. Let's go ahead and substitute it in. 2 plus 3 over 2 plus 5. Right? That's just simple substitution. 2 plus 3 is 5, and 2 plus 5 is 7. This does not equal the 3 over 5 that you said you got when you canceled out your x's and told me the answer was 3 over 5. Okay, so I'm just trying to show you why these doesn't work, but really the reason it doesn't work, these are factors of your original polynomials, P and Q, and they must stay together. And so I personally do like to keep the parentheses just to remind myself that um, I cannot separate them and I can't cancel out those x's. Let's go ahead and let's practice some simplifying. Let's go ahead and let's practice some simplifying. So here's a very common simplifying problem where you have to factor using a GCF. So I can very easily see on the top that I'm just going to think of 2x to the third as its multiplication. In the denominator, I'm going to do the same thing. So I can think of 4 as 2 times 2, and I can think of x as x squared as x times x. I can think of 6 as 2 times 3 times the x from the 6x. Now I can go ahead and I can find a common denominator. What do they have in common? Well, my numerator, 2x to the third, I could think about that as 2 times x times x times x. Anytime I have something like that, I can just think of it this way. If it had been 4, I would have thought of it as 2 times 2 like I did in the bottom. Now, in the denominator, I'm going to go ahead and look, what does this and that have in common? What do these two terms have in common? What's the same? Well, I can see very easily that they both have a 2. I can also see very easily that they both have an x. This is my GCF, and I'm going to start my factoring with that GCF, and then inside the parentheses, I'm going to put what's left. I can see with my 4x squared, I have a 2 and an x, and I can see with my 6x that I have a 3. So let's go ahead and write that down. So remember, once again, I took away the 2x to put it outside. What's left is my 2 and my x. I took away the 2x to put it outside to factor, and I'm left with my 3. What goes in between them? What's right here? Okay, I always get the symbol from right between the two terms originally. Now remember this 2x right here? This 2x right here, your GCF, remember there is multiplication hiding between the two, the x and the parenthesis factors. I need to think of that because this 2 and this 2 will cancel because they're not inside of a factor. There's no plus or minus right behind them, so they will go ahead and cancel. Likewise, this x and one of the x's on the top will cancel as well. I now have nothing else to cancel, and this is my final answer. X times x I would write as x squared, and then on the bottom, 2x minus 3. And remember, it's not necessary, but I do personally like to keep it in the parentheses just to remind myself I can't do anything else. I can't do any get this and get rid of this and then subtract. Okay? But this is my answer. I just don't know if Alex will allow you to leave it in the parentheses. All right, let's go ahead and try one more where we have to factor. So here I have my two polynomials, my p of x in the numerator and my q of x in the denominator, and I have to go ahead and factor them both. So since I have all this space, I'm going to go ahead and take my numerator and I'm just going to rewrite it over here. And I'm going to go ahead and I'm going to factor. So remember, I use my little trick. X squared is x times x. And 27, well, it's negative 27. I need to think of it as 1 times 27 or 3 times 9. Remember, you want to get your middle b term of negative 6x. So to do so, I need 6. I'm thinking 3 times 9. So let's go ahead and put that. And remember, since we have x and x, it really doesn't matter where we put the 3 and where we put the 9. So 3 times x is 3x, x times 9 is 9x. I need to add them together and get negative 6. Well, that would mean the 9 would have to be negative, making this a minus and this a plus. So here is my first factored polynomial, x plus 3, x minus 9. Let's go ahead and take our second polynomial in the denominator, and let's go ahead and factor it. Okay, so let's go ahead and take a look at 2x squared. Well, I'm still going to have x times x for the x squared, but to get 2, I would have to have a 1 times a 2, right? I would have to have a 1x times a 2x. Okay, because 2 is 1 times 2. Now let's take a look at 9. It is positive. I have a choice of 1 times 9 or 3 times 3. Now remember, you want to make a smart choice, so you have to go ahead and you have to look at your B term. Go ahead and look at your B term. 3 plus 3 is 6. 3 plus 3 is 6. Okay, but I need 19. 1 plus 9 is 10. That's a lot closer to 19 than 6. So I'm going to try the 1 and the 9. And if I look at it, I think that if I put the 9 here, 2 times 9 equals 18. I think I'm going to try that. So I'm going to put 9 here and 1 there. And now I'm going to go ahead and crisscross multiply. So that would give me 18x, and this would give me 1x, and I think I could add them together and make them 19x, but it needs to be negative. So that would mean they both have to be negative. And there we go, I factored. Let's go ahead and write these two factors down. Okay, now I'm going to go ahead and I'm going to look at my factored rational expression, and I'm just going to see, does this factor match either of the factors in the bottom? No. Does this factor match either of the factors in the bottom? Yes. This factor and that factor match, so they can be canceled out. Okay, remember they are completely gone. And since there's nothing else that matches, because we already checked, this is your final answer, x plus 3 over 2x minus 1. Next, we're going to talk about how to multiply rational expressions. Just like multiplying fractions, it's just like multiplying fractions. However, when we are multiplying rational expressions, it is much easier to factor the rational expressions before multiplying because factors can cancel out. So we're going to have to go ahead and do some stuff like we did right up here. We're going to have to do some stuff like we did right up here. We're going to have to do some factoring, and then we're going to have to look for some canceling, and then we can go ahead and multiply. Let's take a look at a problem. Okay, so I'm going to go ahead and I'm going to start factoring my polynomials. Now, my first polynomial, x squared minus 4x, my first polynomial, x squared minus 4x, I'm going to think of it as x times x and 4 times x, because there's no c term, there's no constant after my b of x term. There's no constant after my b of x term. So I'm not going to go to my t chart to factor. I'm not going to go to my factoring trick because 0 is a tough one to do the factoring trick with. So I'm going to do a greatest common factor. So remember, it's x times x and it's 4 times x. They both have an x, right? They both have an x. So I'm going to go ahead and factor out an x. So I'm going to start by it being x. If I take away the x from the x squared, I have an x left, minus, because that's what I have right here. And if I factor away the x from the 4, I have a 4. From the 4x, I have 4 left. Now, in the denominator, I thought I could do the same thing, but it's x cubed. and then it's 9x. So I am going to go ahead and take away that x, but I get left with x squared minus 9 in the bottom. Remember, the minus is because that's what's originally there. Now I need to be careful because I know that 9 is a perfect square. It's 3 times 3. And I know that 3 minus 3 is 0, giving me my missing b term. So I can really think of it like this, right? This is called a difference of squares, so I could go ahead and factor this even more than what it's already factored, okay? So we're going to do that in the next step. Times, let's go ahead and take a look at our next rational expression. So I have x squared plus 8x plus 15, x squared plus 8x plus 15. Let's go ahead and use our factoring trick because this is my ax squared plus bx plus c. So I'm going to think of this as x times x. And 15, I can think of it as 1 times 15, or I can think of it as 3 times 5. Since I need 8, I'm going to go ahead and use 3 times 5 because 3 plus 5 is 8. So there's my 3x. Yep, there's my 5x. And that is 8x. There we go, we factored. I feel like we've already done that one. Now let's take a look at the one in the bottom. X squared, and I'm going to have to do this over here on to the side, x times x. My c term is negative 8. So I'm going to think 1 times 8, let's put it up here, 1 times 8, or 2 times 4. Now, one of them is negative, so I need to think about which combo could give me 2. Could give me 2. Don't worry about the negative part right now. Which combo could give you 2? Well, 1 and 8 can give you 9 or 7. 9 or 7, right? 1 plus 8 equals 9. Or I could do 1 minus 8 and I would get negative 7. But I would get a 7, right? 2 plus 4 would give me 6. 4 minus 2 would give me 2. I can get a 2 with the 4 and the 2, so I'm going to go with 2 and 4. And then I'm just going to work it out to see which one would give me my negative when I'm done. Okay, so I know I can get 2x. I'm pretty sure I can get negative 2x, and I can if I make the 4 negative. So plus 2 minus 4. X plus 2 minus 4. Now remember, we haven't factored completely. We haven't factored completely because this one right here can factor more. But before we do, we can go ahead and take a look. Is there anything in my numerators that would cancel with anything in my denominators? Well, the first thing that I notice are these two x's in the front. They can go ahead and cancel. I'm also noticing that here I have an x plus 4, and here, or sorry, x minus 4, and there I have an x minus 4. Since one is in the numerator and the other is in the denominator, and we are multiplying, we can go ahead and cancel these factors out. So let's go ahead and let's cancel those. Okay, and then they don't have to be in the same rational expression for me to cancel. There just has to be one in the numerator and one in the denominator. One in the top, one in the bottom. All right, let's go ahead and factor completely that bottom fraction. I can kind of start combining everything together. So since I have nothing left here, I can go ahead and think of this as my numerator. So I'm just kind of going ahead and I'm starting to multiply. I already know that my denominator is going to have this, but like we said, this is a perfect square. This is a perfect square. So I already know that it is going to factor x squared. I can think of as x times x, and 9 negative, I'm going to think of as 1 times 9 or 3 times 3. Since I want 0, I'm going to use 3 times 3, and I'm going to multiply, crisscross. I can add these together and make them be 0x if this is negative. So I have a positive and a negative. X plus 3, x minus 3. And so now that I've completely factored my denominator, I can go ahead, because remember, this term factored into these two, right? We factored it over there. I can go ahead and take a look. I see x plus 3 and x plus 3. They're going to cancel each other out, and what is remaining is my answer. So goodbye, and my answer is x plus 5 over. And since we are multiplying, it is okay for you to leave it in the factored form. We have completely factored. There is no need for you to go ahead and multiply the denominator. You do not have to go ahead and multiply these out. You can leave it just this way. Let's practice this one more time because multiplication can be pretty tricky. So here are my two rational expressions. We're going to go ahead and we're going to factor. So let's go ahead and take our first polynomial and let's go ahead and factor. Now 7 can only be 1 times 7, so I lucked out there. 1x, 7x. I need to add them together and get 6x. So that would mean the 1 would have to be negative. Okay, that should give me enough space. Oops, that should be a plus. There we go. Okay, let's go ahead and factor this denominator. Okay, so here's another perfect square trinomial, x times x, and 36, I can think of it as 1 times 36. I can think of it as 2 times something, 3 times 12, 4 times 9, 6 times 6 is the one that I want to use because it's a perfect square. And 6x plus negative 6x would give me the 0x that has disappeared from my fraction. Or sorry, from my polynomial. There we go. Times. And of course, you could go ahead and think of this as one big rational expression at this point as well. That's perfectly fine to do. Okay, let's see if I can squeeze these in here. I think I'm going to change my color just to help myself out because it's getting kind of tight in here. There we go. All right, so x squared is, of course, x times x, and negative 24. Let's think. 1 times 24 and 2? No. Hmm. 2 times 12? No. 3 times 8? No, that would give me 5. 4 times 6. 4 times 6, I can make that be 2. 4x, 6x. If I add them together, I'm pretty sure I can get negative 2 if the 6 is negative. Yep, that works. I'm going to go ahead and switch back my color because I don't want to confuse myself that they won't actually cancel each other out if they're not the same color. Okay, I know that sounds really strange, but you might think that. And let's do the last one. Now, what I'm noticing as I'm writing down this last one is that every term in my polynomial is even. Since every term in my polynomial is even, I'm going to go ahead and factor out a 2 as a greatest common factor. So that would give me x squared plus 4x minus 21. 42 divided by 2 is 21. And now I can go ahead and I can factor this polynomial. So I'm going to think of that as x times x. And I have negative 21. I need positive 4. I don't think I'm going to use 1 times 21, but I think I can use 3 times 7. So x times 3, x times 7. I can add those together and get the 4x in the middle if the 3 is negative. Let me go ahead and change my color. Now, yes, I have my x minus 3 and I have my x plus 7. That should be a plus down there. But I also have that 2 that I originally factored out. Now, since I have completely factored all four of my polynomials, I can start looking for things that match in the numerator and denominators, and I can start canceling them out. So one of the first things I notice is that I have this x plus 7 and this x plus 7. Let's get rid of them. One's in the numerator, one's in the denominator. The next thing I notice is that I have an x minus 6 and an x minus 6. Let's get rid of them. One's in the numerator, one's in the denominator. I'm going to check very carefully. No, no, no. Since that one didn't match, none of the rest of them are going to match, and I was not able to get rid of my 2. So my answer is going to be anything like the 2 in the bottom that is not inside a parenthesis, it needs to come first. And then I can put my parentheses, and the order does not matter, but that's what my denominator would look like. And my numerator would be the 2 factors that are left. And once again, you do not have to actually multiply them out. You have already factored, so you are already in the simplified form. Next, we're going to talk about how to divide rational expressions. And it only has one additional step other than multiplying them. Just like when you have fractions, you need to flip the second fraction, flip the second rational expression, and change the problem to multiplication. So you might remember keep, change, flip, or KFC, keep, flip, change. Okay, KFC, you might remember that from Algebra 1. Let's go ahead and start with something like this, where we're going to divide 5a to the third, b to the fourth over 12a, b to the eighth, and we're going to divide that by 15b to the sixth over 8a to the sixth. I'm going to go ahead and leave them the way they are right now, and I'm just going to do the KFC. So I'm going to keep the first rational expression exactly how it is. I'm going to do nothing to it, but copy it down. I'm going to take the second rational expression and I'm going to flip it. So the denominator becomes the numerator, the bottom goes to the top, and likewise the numerator becomes the denominator. There we go. It goes to the bottom. And then I'm going to go ahead and I'm going to change that division that I see to multiplication. Now, I could go ahead from here and I could start thinking of this as, well, I guess I didn't need to change my color. I could think of this as A times A times A and B times B times B times B. It's going to get pretty hard in the bottom because I need 8 B's and I need 6 and 6 here. So I'm going to go ahead and I'm going to go back to my exponent rules. And the exponent rules say when I divide, if I have the same base, top and bottom, I simply subtract the exponent. So I have 3 on the top, I have 1 on the bottom. 3 minus 1 would be a squared. And this works on all of them. So b to the fourth and b to the eighth would be 4 minus 8, which is negative 4. Whenever I have a negative, I cannot simply write b to the negative 4. This is going to go down to the denominator. So if I have this, it's actually going to turn into that. Okay? And then, of course, on this fraction, this rational expression, there's nothing I can do because a and b are different bases. But I can do the a's and I can do the b's here. Okay. I can also go ahead and I can multiply 5 times 8, and I can do times 12 times 15. So here's what I'm going to do. I'm going to go ahead and I'm going to say 5 times 8 is 40. I'm going to go ahead and I'm going to combine together all my A's on the top. Let's go ahead and do that. So I have 3 A's here and I have 6 A's here. The rule says when you multiply, you add the exponents. So 3 plus 6 is 9, and I have my b to the 4th. And then on the bottom, I'm going to go ahead and do 12 times 15, 180, and I'm going to combine together the b's on the bottom, which would give me 8 plus 6, 14. Now, since I have it all combined together, I can go ahead and do that subtraction like I had just shown you. So 40 over 180. I'm going to take my coefficients and I'm going to go ahead and simplify them. Now remember, because they both have zeros, you could cancel out the 0, and you're really doing 4 over 18. 4 over 18, let me see how much room I have down here. That would be 2 over 9. Remember, the rule is we subtract, so it's 9 minus 1, which is 8. That stays in the numerator. And for my b's, it's 4 over 14, so it's 4 minus 14. That would be negative 10, so it's going to the bottom. And it's going to become a positive b to the 10th. Okay, this is my final answer because A and B are different bases and I cannot subtract the exponents anymore. 2 times 9 is a reduced fraction. Okay, the last thing I want to show you is how to divide polynomials where you have x terms, x to the 4th we see in the first one, and then 2x squared and so on. So we're going to go ahead and we are going to factor. We are going to go ahead and we are going to factor. But before we do, we want to do the KFC. So we're going to go ahead and keep the first rational expression just how it looks. Now, I've never seen this before, but if I stop and think, I can do, just like when we have x squared, we do x times x. X squared times x squared would give me x to the 4th. And then this would be 2 times 2 or 1 times 4. And I think I could make that become this when I crisscross multiply. So I think I know how to factor that. I definitely know how to factor the denominator of the first rational expression. But I'm just looking for, of course, are there any, is there a GCF? Since the B term is 1, no, I cannot factor out a 2. I'm going to go ahead and flip. Uh-oh. I'm not liking this new denominator. Okay, that kind of looks funky. Hold on, guys. There we go. That's really making me worried, and I'm going to change it. Okay, so here is my new problem. I'm going to go ahead and I'm going to factor. I'm going to go ahead and I'm going to factor. So let's start with this guy right here. Let's go ahead and factor this guy. So remember, we thought we could think of x to the 4th as x squared times x squared. And that's true. You can think of x to the 4th as x squared times x squared because you would add together those exponents, and 2 plus 2 is 4. Negative 4, I could think of as 1 times 4 or 2 times 2. Let's see, 2 plus 2 is 4, not 3, and 2 minus 2 is 0, once again, not 3. So I think I'm going to use 1 and 4 because I think that they're going to help me when I crisscross multiply. Okay, so that would be 1x, and this would be x squared. I think when I add these together, I can get negative 3x squared. Yep, I just got to make the 4 a negative. So this is minus, this is plus, and we've gone ahead and factored our first polynomial. And that one, I have to say, was the scariest. Now, 1 is a perfect square. I need to be careful because 1 is a perfect square. 1 times 1. But 1 plus 1 is 2. And I would have to have a minus for this to be able to factor. So this one cannot factor anymore. You only have the difference of perfect squares when it's a minus. Okay, so I need to be careful. This will actually factor more. This will factor into x and 2 and 2, 1 plus, 1 minus, because it is the difference of a perfect square. Let's go ahead and let's factor this polynomial. So let's bring it down here and let's factor this one. So let's see, 2x squared would be x and 2x, right? Because 2 I need to think of as 1 times 2, and then the x squared gets an x and an x. 10, 10 I would think of as 1 times 10 or 2 times 5. I'm going to go with 2 times 5. Um, I'm not really sure where to put stuff, but I'm thinking maybe like this. I'm going to give this one a try first. I'm not really sure if this is going to work. I might have to flip them, but it's okay. Remember 2x times 2 is 4x. That's 5x. I add them together and I want 1x like I have right here. I think I did it. I just have to make this one a minus and it'll work. Perfect. There we go. So there's my second one factored. Let's go ahead. We already said we knew that this one right here is going to factor more. So let's go ahead and let's factor it more because we already said we knew it was going to be x plus 2 and x minus 2. So let's go ahead and do that already. I'll go ahead and write up here that it had started as the difference of these two squares. I'll add that in there for you guys. Okay. Now, in the second one, in the second rational expression, you might be thinking, oh, miss, this is taking forever. But take a look at your numerator. It's already factored. It's already factored. Let's just put it parentheses around it. And what we're going to do in the second one, in the denominator of this second rational expression, is we're going to go ahead and, excuse me, we're going to factor by grouping. If I put these two together, I can pull out a GCF. And if I put these two together, I can pull out a GCF. So I'm going to go ahead and do that. I'm going to grab, ooh, I hope this color will work. I'm going to go ahead and grab this color and I'm going to come down here and I'm going to say x to the third minus 3x squared. And then I'm going to think of it as x minus 3. So I'm going to kind of split it up. There is a plus here, but I'm going to look specifically at these two first, and then I'm going to look at those two next. Now, x to the third would be x times x times x, and this one would be 3 times x times x. They both have two x's that they could give to a GCF. So I'm going to start, I'm going to start by saying x squared. If I take that x squared away from each one, I have x minus 3. Now, if I take a look at this next one, x and 3, I can only think of this as 1 times x and 1 times 3. So the only thing they share is that 1. So I'm going to pull that GCF out and leaving me with my, right? And of course my plus is in here because I pulled out a positive 1. I have factored this. I know you're not going to believe I have, but I have. Here is one of my terms. I'm not going to write it twice. I'm only going to put it once. Okay, because it's the same factor in both, it's one of my factors. My second factor are my two GCFs. There's my second factor. And I have now completely factored. Now I can go back and I can start canceling out things that are the same, like that x squared plus 1, like anything else to cancel out? Nope, I've completely canceled everything out. So on the top, I'm left with x plus 2 times x minus 2. Remember, you do not have to multiply it out. And 2x plus 5 times x minus 3.